we're going to do a little experiment. We're going to see if we can eliminate this entire motor, pump, assembly, everything. Just remove. Instead of having all this to power that side and all this to power this side, we're going to power both sides with one motor. Stand by. Hydraulically, that's easy to do. All we need to do is take these hoses and connect them differently. At first glance, it looks like a whole bunch of mechanical nonsense, but what we have is one engine turning one hydraulic pump, taking oil from this tank, pressurizing it, and sending it forward to that valve, which is driving this track. The other engine is also taking oil from this tank, pressurizing it through that hydraulic pump, and sending it through that hose to that valve, to that wheel motor. Now how it works is, when the valves are in the neutral position, the oil goes through the pump, through the valve, back through that filter and back to that tank in a constant cycle of hydraulic pumping. When you push the valve into the forward position, it sends the fluid through the wheel motor, making the track turn. Forget this exists. Everything from here over. So you have diesel fuel running the engine. The engine is turning. Therefore, the hydraulic pump is turning. They're connected on a shaft right here with a coupling. This pump is turning. It's pumping oil. It's taking oil from this tank. It's coming through this hose. It's pumping it through this hose at high pressure. That available pressure is going to that valve on the left. It's making the track turn forward or reverse or neutral, depending on the valve position. Now, my theory is, instead of the return flow going back to the tank, let's use that return flow to power this valve and this side. So basically take the exhaust from this valve and turn it into the inlet to this valve. In effect, we're putting them in series. It's really a simple case of plumbing. All we have to do is take the return flow and plumb it back in to the inlet flow. So once I release this fitting here, a whole bunch of oil is going to pour out. That entire tank is going to empty through this hose. And this oil costs like $5 a gallon, so let's try to collect every drop if we can. There it goes. That is thick as molasses. Yeah, we'll come back in a few hours. This is the main pressure side. That's the main return side. And both hoses are just seeping into this bucket real slow. So we're gonna come back in a couple of hours. And once this entire side of the hydraulic system is completely bled out, we're going to connect these hoses to this side and take all the hydraulic pressure and flow from this reservoir and this engine and this pump and basically run the entire tank off of only the port side or left side engine. Slowly but surely, this oil is trickling out. At first glance, it looks like a mess of nonsense, but effectively all we need to do is take the return hose, which is here, and run it to the input, which is there. But unless we want to spill hydraulic fluid everywhere, we just have to patiently wait until it slowly drains out. Next order of business is to disconnect this high pressure output line from the starboard engine, unwrench that, and connect it to the input of the port side. We got the fitting nice and loose. We're going to disconnect it and let it seep oil into this drain pan. Whenever you disconnect hydraulic fluids, expect a bunch of seepage. There it is. It's cold, so it's going to seep really slowly. We're in no rush, so we're just going to let this seep until it stops. It'll drain, it'll seep. So that's disconnected and plugged. The excess fluid is seeping into that pan. Once the hose is completely drained, we'll take it and we'll connect it to that side. So the outflow from this side is gonna come back and be recycled to power this side. So this stuff is like $100 for a 5-gallon bucket. I'm trying to save every drop that I can. Draining the entire reservoir for the starboard side. I got the main suction hose disconnected, trying to get every last drop of hydraulic oil because this stuff ain't cheap. So with minimal spillage, this side has been completely capped off, both the pressure side and the return side. All the drippage has been collected, the filter's been collected, all the oil has been collected, and waste not, want not, I dumped it all back into this side. So this tank is completely full. This engine is plumbed through both valves, and all of this is basically amputated and can be removed, drained, capped off, ready to remove. This side is completely full, hooked up, and ready to run. So let's test it and see, do we really need 2 engines, or can we run the entire thing off of just one? Now we find out.
Engines don't like to start when it's fucking freezing cold. Yeah, winter sucks. We're just gonna let that run and warm up for a while. This is the injector pump. That's what runs the engine's fuel injector. There's a camshaft inside of there that's pushing the push rods and making the valves open and close. But it's also running this. Every time that cam comes around, it pulses that fuel pump, sends a pulse of fuel at just the right time. You can increase the amount of fuel with the throttle. This screw sets the idle speed. The slower this is, the further this can come up. It's supposed to be a generator engine, so you're supposed to set it at a constant throttle. Lock it down.
So I got everything hooked up and I did a little test and it actually works. However, the back pressure is so high that this gauge just buried itself. I mean, like 4,000 PSI. I was just bracing for impact, expecting one of these hoses to explode, but it held, but it bent the needle. Like, it's reading 500 PSI and it's off. So I don't even want to try and do that test again on film because that was fucking dangerous. But it does work, I guess. Both tracks turn. I did a full 360. It wasn't until I tried to do one track forward, one track backward. That's when the gauge really buried itself. But if you don't try to do anything like that, this does work. However, the permanent solution is to get a flow divider and basically tee those together instead of trying to run them in series. If I was going to run them in series, I would need to get a combination, like a two-spool valve, where it's basically both valve bodies in one block. And that way the relief pressure can bleed around. Because right now, when this hits its relief pressure, there's a safety valve in there so that you don't explode things. When it gets to 3,000 PSI, that valve bleeds the pressure off. But where it bleeds to is the return line, and the return line is supposed to have free return to the tank, to the reservoir, but we have it plumbed around to the input of this side. So when this is overloaded, it's trying to bleed off pressure. It has nowhere to go except through this side, which is also trying to do work. So this side is safe and functions perfect. This side is safe and functions perfect, but when you try to do one forward, one back, it's just too much pressure on the system. So we're going to need a flow divider, or we're going to need a combination valve, two-spool valve. So actually what I did was I put both of these valves on eBay, and if they sell, I'll buy a different valve. But either way, our little test was successful, and nobody got hurt. No hoses exploded. You can start that engine and move the tank around the garage. This engine doesn't need to run. That's all getting removed. That's all going to become a motorcycle or something. And it's all capped off and drained and ready to amputate. And the rest of the tank is drivable on one motor.